see the screen? Yeah, okay. So coming to the discussion, just a brief intro. If we are talking about complex number, here we are talking about complex number. No? So complex number can be represented in three different forms: x plus iy, or a plus ib, r into e power I theta, and r into cos theta plus I sin theta. Okay. So just the conditions for these two, your r must be positive, and that's it. Okay. Your theta is called the argument. And if theta lies between pi and minus pi, then it is called principal argument. Okay. Let us see how to find the argument of all those things also. Okay. So if a complex number given is in this form, for example, okay, so whenever a complex number is given, you convert it into one of the forms to find out what is the argument, principal argument, r. Okay. R is nothing but the modulus of complex number. Okay. So some important properties, basic properties already you guys will know, that is mod of z1 z2 is equals to mod z1 into mod z2. Okay. Argument of z1 z2 is equals to argument of z1 plus argument of z2. So all these things, yeah. Okay. So just one thing which normally students miss out, and very important formula, this one. See, there is a difference between z1 plus z2 whole square and modulus of z1 plus z2 whole square. What is the difference? Like for example, 2 plus I whole square is there. You write it as 4a square plus b square. B square is minus 1 plus 2ab, 4i. It is 3 plus 4i. But whereas mod of 2 plus I whole square is, mod 2 plus I is root 5. Root 5 square, which is 5. Okay. So both are different. No? One is always a real number, other one is a complex number. Okay. Yeah. Now, this one is straight away, it is like a plus b whole square, z1 square plus z2 square plus 2z1 z2. It is simply z1 plus z2 into z1 plus z2. Na? It is just multiplication, directly do like that, you will get. But mod z1 plus z2 whole square, what will that be? Okay, let us see. For example, if you have a z1 plus b z2 whole square is there, you can write a square z1 square. It is not modulus, just simply square, plus b square z2 square plus 2ab z1 z2. Okay. It is just like ax plus by whole square. You know how to do, na? A square x square plus like that. When modulus is involved, the formula will be mod z1 square plus mod z2 square plus 2 times mod z1 into mod z2 into cos of alpha. What is alpha? Alpha is angle between the complex numbers z1 and z2. You may say, sir, what is the angle between the complex numbers? Because complex number is a number. No? Number means what is the angle? We'll come to that later. So another way you can remember this is alpha is argument of z1 by z2. Okay, like that also you can remember. I'll come to that in just 2 minutes. What is angle between complex numbers and all? Okay. Now, there is another formula. Mod z1 plus z2 whole square is mod z1 square plus mod z2 square plus z1 z2 bar plus z1 bar z2. Okay. Like this also you can write. Or there is another way you can write mod z1 square plus mod z2 square plus 2 times the real part of Z1, Z2 bar. How did I write this one? Because with this formula, many things you can recall. How I am writing 2 times real part of this? It is because there are 2 terms, Z1, Z2 bar plus Z1 bar, Z2. Now, what is Z1, Z2 bar, whole bar, conjugate of Z1, Z2 bar? It is Z1 bar, Z2 bar bar. Because conjugate rule is what here? Z1, Z2 whole bar can be written as Z1 bar into Z2 bar. See, these basics rule you must know. Okay. Just revise if you are forgetting it. Now, this is Z1 bar, Z2 bar is Z2 only. So that means the conjugate of Z1, Z2 bar is Z1 bar, Z2. So Z1, Z2 bar, Z1 bar, Z2. Both are conjugate to each other. No? If this is, so it is like Z plus Z bar. What is Z plus Z bar? 2 times the real part of Z. Correct? Because if Z is X plus Iy, Z bar is X minus Iy. What is Z plus Z bar? 2X. Na? That is 2 times real part of Z. Okay. Or you can write it as 2 times real part of Z bar also. Because real part of Z and real part of Z bar, both will be same only. Na? Okay. So that means if Z1 is conjugate to Z2, it implies Z2 is conjugate to Z1. Okay. That means if Z1 is conjugate to Z2, Z2 bar, apply bar on both sides, Z1 bar will be equals to Z2 bar, which is Z2. Okay. So if Z1 is conjugate to Z2, remember this one. Why? Because you see here, if I am saying that Z1 bar Z2 is conjugate to this, it means this is also conjugate to the second one. Okay. So what is the final statement which I am writing here? Now you understand this one. I have written 2 times real part of Z1, Z2 bar. Why? If this is Z, then this will be Z bar. So you can write like that. Na? Z plus Z bar is 2 times real part of that complex number. Or you can write it as mod Z1 square plus mod Z2 square plus 2 times real part of Z1 bar Z2. Okay. So this is Z, this is Z bar. So you can treat it like this. You can say this is Z, this is Z bar. Or someone else may say, no, this is Z, this is Z bar. That means that is the complex number. This both are same only, na? Just now we have seen. Okay, if Z1 is conjugate of Z2, then Z2 is conjugate of Z1. Okay, so 2 times real part of Z. That Z can be either this or this. Okay, anyone you can do. This is one formula which we come across very frequently. Now this only, like if you have mod of AZ1 plus BZ2 whole square, then same thing, just like you do AX plus BY whole square, A square mod Z1 square plus B square mod Z2 square plus 2AB times real part of Z1 bar Z2, or you can write plus 2AB times real part of Z1 Z2 bar. First complex number, second one conjugate. Okay, everything else will be same. So this is one formula which is very important. Okay, but students tend to forget. The other application which is very important is this. Okay, we'll see that application in some questions also. The other application is, if in the question, if they are saying Z is real, okay, if a complex number is real, it means Z plus Z bar will be 0. This is the condition which you need to apply. Okay, if someone is saying complex number is real in the question, they will give something. They will say complex number. What condition you have to apply now? But this condition, because what is Z plus Z bar? 2 times real part of Z. Acha, acha. Real they have told, na? Okay, sorry. If a complex number is real, then imaginary part of Z must be 0, na? Not the real part. Okay. So that means if Z is the complex number X plus Iy, what will be Z bar? X minus Iy. If you subtract both Z minus Z bar, what do you get? 2Iy. So that means 2I times imaginary part of Z. So if Z is real, this is 0, na? So then you will say Z is equals to Z bar. If a complex number is real, then that complex number will be equals to its conjugate, no? Like that. So if Z is purely imaginary, if they have given, then you have to apply the condition Z plus Z bar must be 0. Okay. Real part must be 0, no? Like that. So remember these two conditions, guys. If Z is real, then you have to apply the condition Z equals to Z bar. Then some conjugate conditions will be, properties are there. Using that, you have to solve the question. Okay. The other one is Z plus Z bar equals to 0. Okay. Now, previously I have told that Z angle between vectors I have mentioned, no? Some terminology. Okay. Let us just see. Very important, guys. Focus. Now, you all know what is vectors. Okay. In vectors also, you all know what is meant by position vectors. Okay. Position vectors. What is a position vector? A vector pointing from origin to a particular point. That vector is called position vector of A, and it is in bracket we will write A bar. Okay. So whenever if I write B comma B bar, it means the position vector of B is what here? B bar. That means from origin, if you point B, that vector will be B bar. Same way, you will be seeing that, okay, I have written X and Y, but actually what I should write in case of complex numbers, real axis, imaginary axis. Okay. So if I take any point P, in bracket, if I write Z, what does it mean? It's the same meaning as position vector. That means if I join from origin to that point, that vector is Z. Okay. Now, the angle made by that vector with positive real axis is only argument. Okay. The length of that vector is only mod Z, modulus of that complex number. The length of that vector is Z, na? The length is only modulus. Now, for example, in the space, if I have 2 points, okay, let me take one point A, other point B. Okay, let's say somewhere here. In bracket, if I write Z1, what is that Z1? From origin, if I point out that point, then that complex number will be Z1. Now, in bracket of B, if I write Z2, then that means from origin, if I point B, that vector is Z2. Now, what will be this one? In vectors also we do, no? If you have A bar, B bar, then this vector will be final position minus initial position, B bar minus A bar. So here also it will be Z2 minus Z1. Now the angle made by that vector with x-axis, real axis, that theta, okay, that is called argument. So here theta 1, let's say, argument of Z2 minus Z1 will be what? Theta 1. And what is modulus of Z2 minus Z1? That is length AB only, distance, length of that vector. No? Okay. This is what I was mentioning previously. Z1, Z2 are two vectors. The angle between them is alpha. That is what I have written in this formula. Okay. Where is that one? Yeah. 2Z1, Z2 cos alpha. Okay. Fine. Let us use all of them in some questions. Okay. 1 second. So there are some. Yeah. Let us see this one. Fine. So normally there is one more point which I wanted to explain through questions only. See, normal issues are these only in complex numbers. When to use which one? Okay. We'll address this issue through questions. Okay. For example, if I take this one, mod Z1, mod Z2, both are same. They have given argument of Z1 plus argument of Z2, they have given pi by 2. So that means R1 equals to R2. Let's say that is R. Okay. And theta 1 plus theta 2 is pi by 2. Then they are asking some questions. Z1, Z2 is purely real, purely imaginary, something. They are asking. So what you do is Z1, can I write it as R e power I theta 1? Then what will be Z2? R e power I theta 2. That is, now what will be Z1 plus Z1, Z2? It is r e power r square e power I theta 1 plus theta 2. What is theta 1 plus theta 2? Pi by 2. And e power I pi by 2 is I. So r square times I. This is real number. So it is like some 9i, 69, something like that. So purely imaginary, na? Like that. Okay. So here, if you use Euler's form, it is easy, na? Now let us say second one. This one here. They have given Z1, A1 plus IB1. Z2 is A2 plus IB2 are complex numbers such that they have given the modulus and real part of Z1, Z2 is 0. Okay. What does it mean real part of Z1, Z2 is 0? It means Z1, Z2 is purely imaginary. Okay. If any complex number is purely imaginary, then its argument will be either pi by 2 or minus pi by 2. Okay. Now, coming to this. See, the very in complex numbers, this is the beauty of the questions. They will give one information, but with that one information, you have to interpret that information differently. Okay, to solve the question. Okay, even though both are same, but this is not going to help in solving the question. These are going to help. Okay, let us see how. Okay, then the pair of complex numbers. So they have given some information about Z1, Z2. They have used whatever A1, A2 are there. They made new complex numbers, omega 1, omega 2. They are asking some questions on that one. Okay, let us see how to solve this one. Okay. Okay. So argument of Z1, Z2 is nothing but theta 1 plus theta 2. So let us take pi by 2. It can be minus pi by 2 also. One of them you have to take, na? Okay, let's take pi by 2. Then what will be Z1? Modulus is 1 times cos theta 1 plus I sin theta 1. That is Z1. Okay. What will be Z2? Modulus is 2 times cos theta 2 plus I sin theta 2. 2 times, what is theta 2? Pi by 2 minus theta 1. If you substitute sin theta 2 plus, sin theta 1, because pi by 2 minus cos of pi by 2 minus theta 1, sin theta 1, plus I cos theta 1, like this. Now, already they gave what is Z1 and Z2. This is A1 plus IB1. This is A2 plus IB2. So now you compare A1 is cos theta 1, B1 is sin theta 1, A2 is 2 sin theta 1, and B2 is 2 cos theta 1. Okay. Now what is omega 1? Write down. A1 plus I times. What is A1? Cos theta 1 plus I times A2 by 2. A2 by 2 is sin theta 1. Write down what is omega 2. 2B1. What is 2B1? 2 sin theta 1 plus I times B2. What is B2? 2 cos theta 1. That's it. Okay. Now they are asking some questions. Mod omega 1 is 1. Correct only, no? Because 1 times cos theta 1 plus I sin theta 1. So modulus of omega 1 is how much? 1. A is correct. Mod omega 2 is 2. 2 only, no? Because if I modify this, what will I get? 2 times sin theta 1 plus I cos theta 1. So modulus, if you apply, you will get 2 only. Sin square theta 1 plus cos square theta 1 times. Okay. Next. Real part of omega 1, omega 2. Imaginary part also they are talking about. Okay. Now what is there? You can multiply these two. It won't take much time. Then you can find out for yourself what is the, okay, this thing. Fine. Next. This is a very interesting question again on argument and all. See, we are now looking at argument, modulus and all. 1 second, guys. Just 1 second. Yeah, sorry guys. We'll continue. Yeah, where were we? Yeah, coming to this one. So let us see this. What is that one? Z bar plus I times omega bar. Omega means not cube root of unity here. Okay. And they have given argument of Z omega. Argument of Z omega is pi. Then they are asking argument of Z. Okay. Now you see, very simple one. Okay. Let's say argument of Z is theta 1 and argument of this W, whichever is there, is theta 2. Okay. Then what is argument of ZW? Theta 1 plus theta 2. How much it is? Pi. Okay. Let's say equation 1. Now, if you observe this one, what is Z bar? It is minus I W bar. Correct? Now, or you can say Z bar is IW whole bar. You can say like that, no? Because I bar is minus I. So you can apply conjugate on both sides. You will get Z is equals to I omega. Okay. So if you understand rotation, directly I can write here that theta 1 is equals to theta 2 plus pi by 2 directly. Or let's say, because rotation I'll come to it later. Okay. After like 5-10 minutes. Well, let's say forget about rotation. Just apply argument on both sides. Argument of IW. What is argument of Z? Theta 1. What is argument of Z1, Z2? Argument of Z1 plus argument of Z2. Like this I can write. No? So theta 1 is equals to argument of I is pi by 2 plus theta 2. Anyways, you will get this. So two equations, two unknowns. You can solve for theta 1. No? Okay. This is previous JEE question. Very simple. The idea which you should get is the how to get this relation. You may get that idea either from rotation or by applying argument on both sides. Okay. That is the logic here. Okay. Next one. Same way. Another question is given. Theta 1 plus theta 2 is pi by 2. Same model. Now apply argument on both sides here. If you apply argument on both sides, then argument of 1 minus I plus argument of Z1 is equals to argument of 2 plus argument of Z2. That is what you get. Now, argument of positive number is 0. Argument of negative number, minus 2, minus 3, minus 30, whatever it may be, that is pi. Okay. Because negative real number will be on negative real axis. No? Then its argument will be what here? If that is the vector, then this angle pi only. No? Okay. Again, I'm not touching that one because I hope that fundamentals you already know. Okay. So then it's the same question more or less. Fine. Yeah. Next. This is very important model, guys. Very like IIT JEE itself has asked this question twice. So I just want to stress on this question. Advanced I am talking. In advanced only, generally in advanced questions will not be repeated. Okay. Now coming to this question. See this question, there are other forms also. See, they didn't ask exactly the same question. They changed it little bit. They told mod Z square minus 4, something like this, equals to mod 2Z. Then the greatest value of mod Z. Actually, if you take LCM, you will get this only. Okay. More or less same. Now, here what is important means there is something called triangle inequalities, no? In complex numbers. Very easy to remember, mod of Z1 plus Z2. Okay. Mod of Z1 plus Z2 is always less than or equals to mod Z1 plus mod Z2. You can remember it, 2 is one complex number, minus 3 is another complex number, modulus is 1. But if you add individual modulus, what will you get? It is more, no? Or you can think of it as sum of two different sides of a triangle is greater than the third side, like that. Okay. Next, and also another inequality we have, mod of Z1 minus Z2. Okay, is less than or equals to mod Z1 plus mod Z2. Okay. Because actually, the above one, if you have understood, sum of two sides like that. The below one also, I have written minus here. So I can write it as minus Z2. plus minus Z2 is less than or equals to mod Z1 plus mod minus Z2. Mod minus Z2 is same as mod Z2. No? Okay. And other one is mod of Z1, 4 are there totally. Mod of Z1 minus Z2 is always greater than or equals to. In a triangle, one side will be always greater than difference between other two sides. No? So mod Z1 minus mod Z2. But you put a modulus over there because we don't know which side is larger. No? When I say difference, it means larger side minus smaller side. So since we don't know, we are putting modulus. Okay. And last but not least, mod of Z1 plus Z2. Again, same. For everything, for Z1 minus Z2, we have used the sum as well as difference. No? Sum of two sides, difference between the sides. Same way, for mod Z1 minus Z2, it is always greater than or equals to difference between the sides. Mod Z1 minus mod Z2. So total 4 inequalities are there. Okay. That's all. This question is that only. Now coming to this question, mod of, what is there? Mod of Z minus 4 by Z is equals to 2. Na? Now, that means which two inequalities we are going to use? These two. Okay. Use those two inequalities. How? You see? Mod of Z1 minus Z2. Different. So one side. That is what here? 2. Okay. It is always less than or equals to difference between the mod Z, mod Z minus mod 4 by Z. This is one inequality and modulus over there. And another inequality, this will be greater than or, sorry, not less than. Greater than or equals to. Because mod of Z1 minus Z2, that is 2. So if I'm writing 2, that is mod Z1 minus Z2. That is greater than or equals to mod Z1 minus mod Z2. Same way, the other inequality will be, it will be less than or equals to mod Z1, that is mod Z plus mod Z2, mod 4 by Z. Okay. That's it. Now, after this, it is no more a complex number question. Done. How I will tell you. Okay. If I take the second inequality, what is it? Mod Z is nothing but R. No? Some length of that vector. Let's take it as R. So 2 less than or equals to R plus 4 by R. Now, if you take it R square minus 2R plus 4 greater than or equal to 0, that is the inequality. Now, this is the inequality which you solve in quadratic. No? Now, this is simply R minus 1 whole square plus 3. When is it greater than or equal to 0? Always. We'll get R belongs to all real numbers. So, no matter what is the value of mod Z, this inequality is always going to satisfy. Okay. Then we have the other one here. So 2 greater than or equals to modulus of R minus 4 by R. Correct? So whenever something, modulus of something is less than or equals to 2, what does it mean? That something whichever is there, R minus 4 by R, it must be less than or equals to 2, greater than or equals to minus 2. You will get two inequalities. R minus 4 by R greater than or equals to minus 2. R minus 4 by R less than or equals to 2. Solve these two, take intersection, you will get the answer. Okay. And if you are not familiar with solving these inequalities, the method which is, I may solve this one question, but you should be familiar with that method also. No? That is wavy curve. Okay. So if you are already familiar with it, very good. Otherwise, very important method. It will come very frequently for solving inequalities. Otherwise, you have to go ahead and prepare today. Okay. Next. Some more, 1 second, some more model. Yeah. So this is the model which I want to explain very clearly. You see here, this they are saying is unimodular. Unimodular means modulus is 1. They have mentioned also. This is previous JEE advanced question. Okay. Then find mod Z. Z1 they are asking. And they have given mod Z2 is not equals to 1. That is what they have given. Okay. So let's just apply the condition. They told this is unimodular. So modulus of Z1 minus 2Z2 by 2 minus Z1 Z2 bar, this is equals to 1. Just cross multiply properly. 2Z2 is equals to mod of 2 minus Z1 Z2 bar. Now square on both sides. If you square, you remember this formula? Just now we have told, no? Z1, AZ1 plus BZ2 whole square, modulus. What is the formula? Mod Z1 square plus 4 times mod Z2 square minus 4 times real part of Z1, Z2 bar. Okay. One complex number into other one conjugate. You can write Z2, Z1 bar also. Okay. Anything, one complex number, any one complex number into other one conjugate equals to right hand side 4 plus mod Z1, Z2 bar whole square minus 4 times a real part of. Now we will take this complex number. The other complex number is 2 into 1 only. No? Okay. That conjugate of 1 is 1 only. So that one Z1, Z2 bar we will write. Okay. If you are choosing that, okay, I will take this, sir, this one conjugate I will write. 1 into, what is the conjugate of Z1, Z2 bar? Z1 bar, Z2. So real part of this. So if I write like this, then, sorry. If I write like whatever I have written right now, then it is pretty clear that these two gets cancelled. But by mistake, you have, see, you can make any choice. No? By mistake, not by mistake. It is also correct only. If you have written like this, still you should realize that Z1 bar Z2 is nothing but conjugate of Z1 Z2 bar. So real part of Z as well as real part of Z bar both are same only. Na? So you can still cancel them if these two are equal or like that on both sides of equality. If they are there, you can cancel. That's it, guys. Now it is done. R1 square plus 4 times R2 square is equals to 4 plus, what is this one? This is mod Z1 square, mod Z2 bar square. Now this is R1 square only. Mod Z2 bar or mod Z2, both are same only, R2 square. So if you factorize this, you will get mod Z1. Okay, that is R1. You will get it. Okay. Next, this only I was talking, rotation. Okay. So just if you have a vector, again, I'm saying vector. I'm saying complex number as a vector, not some number. If you have any vector, okay, concentrate this. Let's say that vector is Z. Now, you will not change the initial point whenever you are doing the rotation, correct? Now, if you want to rotate this complex number by some angle in anti-clockwise direction, just some rotation by some angle alpha, you will, this violet color one is a new vector. Let's say that vector is Z1. If you rotate this complex number by some angle in the anti-clockwise direction, beta, you will get a new vector. Let's say that is Z2. Then if you, that Z1 will be nothing but Z into e power I alpha. So whatever angle by which you are rotating, that unit vector you will multiply e power I alpha. E power I alpha modulus is how much? 1 only. Na? Okay. Whenever you multiply by e power I alpha, the argument of the complex number will increase by alpha. What is meant by argument increasing by alpha? The angle made with real axis is increasing by alpha. Na? That means you are rotating it anti-clockwise or not. Okay. Now, if you want to rotate it clockwise, then what you have to do? If you want Z2, then it is Z into, initially you started with Z into e power minus I beta. How much angle you are rotating? Beta, but clockwise, na? So that's why this minus. Okay. This is only rotation. Fine. Now, how do we use the rotation? For example, there is a question that is rotate. Sorry. Rotate in 2D. You have this question. Rotate the point. Let's say 5 comma minus 1 with respect to 2 comma 1 by 90 degrees. Okay. Then the final position of 5 comma minus 1 is dash. That means which point you are rotating? 5 comma minus 1. Let's see, randomly I'm drawing. Don't think geometrically, sir, that is not where 5 comma minus 1 will be. No, it doesn't matter how you draw. 5 comma minus 1, let's say it is B. So you're rotating about which point? 2 comma 1. Let's say that is A. Now, can you tell me what is this complex number? This one, this vector, it will be 3, difference in x coordinates. That is the real parts, na? And y coordinate difference minus 2i. Done. Now, what they are asking, you are rotating this point, okay, 90 degrees anti-clockwise, let's take. Clockwise also, it doesn't matter, okay? You will get it easily, any one of them. Okay, anti-clockwise, if you're rotating, that point means this will be the final vector, correct? This 90 degrees. Now, if this is z, then what will be this green color vectors? Z into e power I pi by 2. Agreed? What is e power I pi by 2? I only, no? So this z, if you multiply with I, you will get 2 plus 3i, no? Correct? 3 minus 2i into I. It will be 2 plus 3i only, no? You know that vector. So like for example, if I know 1 comma minus 3, if I know this vector 2 plus 7i, what will be the final point? 2 plus 1, 3, 7 minus 3, 4. Okay. Initial point plus that vector, because if this is a bar, this is b bar, this vector is v bar, b bar minus a bar is v bar. No? What will be b bar? Initial a bar plus the vector. No? So to this initial point, what you need to do? You have to add the vector components. You will get the final point. What is it? 2 plus 2, 4. 3 plus 1, 4. That's it. This is the final point. Okay. I hope you have understood this one. Okay, there are some questions based on that one. Same thing. Okay. Yeah. Fine. So there are a lot of questions. Okay. Some 70-page questions are there. Okay. So let us focus our attention on our next topic. See, I hope that cube roots of unity and all, you guys will read. Okay. Will be able to read yourself. That is simple topic only. Okay. 1 second, guys. Yeah. I want to discuss a bit of binomial theorem. Okay. The things which are important. Okay. You all know binomial expansion and all those things. Okay. See, there are questions on finding the coefficient and all these things. Okay. Let me give you one such question, very important question. Okay. That question should explain a lot of things. Okay. Just give me a moment. Yeah. So the question says, find the coefficient of t power 24 in 1 plus t square whole power 12 into 1 plus t power 12 into 1 plus t power 24. Okay, this is the question. Now, what you need to understand is how the multiplication works. Okay. For example, if I give you, because if you understand this, any questions which are like this can be solved. Because, yeah, I think if the question is given like 1 plus, or like you see the questions x plus 1 by root x whole power 10, find the coefficient of some x power something, 3 or something like that. Okay. You will write the rth term and then you will know. In board also they are there. Okay. I'm not touching that part. I'm hoping that you guys already know how to solve that basic questions. Okay. Now, if product is given like this, more than one binomial expansions are multiplied. Okay. Then how to solve this question? See, you should understand how the multiplication works. I will give you 30 seconds for you all to solve this question. Okay. X power 5 minus 7x square plus 4x minus 5 into 2x cube minus 4x square plus 3x minus 1. This is a polynomial. Agreed? Okay. So in this polynomial, first question, there are some questions which I want to ask one by one. Okay, I'll write down, you answer. What is the coefficient of x power 6? Okay. Second, sum of coefficients of all terms after expansion. That means after after you expand this, you remove these brackets, you will get a big polynomial, right? So for that polynomial, then what is the sum of the coefficients of all the terms? Of terms with even power of x. Next, last one, sum of coefficients of terms with odd powers of x. Okay. Now, let us understand the first one, x power 6. Okay. See, there are three bunches, you can say. Let's say there are, think of it like this, three baskets are there. First basket, the number of fruits, amount of, you can say in each baskets, there are some packet of fruits. There is one empty packet, that means 0 fruits are there. There is one packet where 1 fruit is there. One packet where 3 fruits are there. Another packet where 4 fruits are there. Like that you can imagine. And what I have written here are nothing but the powers of x of each terms. Okay. This is basket 1, you can say. There is this basket 2, where there is 0, there is 1, there is 2, there is 5. What I have done, just I have written the powers of x. Basket 3, 0, 1, 2, 3. That's all. Okay. Now, when you are multiplying, so there are 3, sorry, like this it is there. So now I can say basket 1, basket 2, basket 3. Okay. Now, so if I ask you to pick 6 fruits from, you can choose any number of baskets and whatever you want. What you will do? One possibility is choose 1 here, 5 here, and 0 here, 6 you will get. Okay. So you'll just have to list down all those possibilities. Okay. Sometimes, see, this is little difficult question. That's why it will be little lengthy. But it's okay. You just will do this question. Some things will be clear. We need coefficient of x power 6. So what you do? Randomly, if you do, you may miss something. Okay. So do it in order. What you do? 0. Start with this. Then take the starting one. Any 6 is there? Not there. Leave it. Start with this 1. 6 is there? No. Sorry, 5 you have to see. 0 plus 1 plus 5, not there. 0 plus 2 plus 4, not there. Okay. 0 plus 5. 5 plus 1. Yeah, it is there. So that means one combination is 0, 5, 1. Okay. Next you have to see. So what does it mean, this combination 0, 5 and 1? That means if you multiply this x power 0, x power 5 and 1 means 3x, you will get x power 6 term. No? So when you are multiplying, what you have to do? You will multiply the coefficients. So I have written 0. So you know that is combination is 0, 1 and what here? Sorry, not 0, 1 and 5. 0, 5 and 1. Okay, we'll do one thing. We'll just list down all the possibilities. Next, with 0 it is over. No? Next with 1. 1, 0, then 5 must be there, not there. 1, 1, 4 must be there, not there. 1, 2, 3 must be there. Yes, it is there. 1, 2, 3. Okay. Next. Sorry. 1 second. 1, 2, 3. Then 1, 5. 0 must be there. Yeah, 1, 5, 0. Done. Now after this, start with again 3. 3, 0. 3 must be there. Yeah. 3, 0, 3. It is there. Next. With 3, 1. 3, 1, 2 must be there. Yes, it is there. 3, 1, 2. Next. 3, 2. 5, 5 plus 1. 3, 2, 1. Okay. Now I'm keeping on listing down. Okay. 3, 5. It is exceeding 6. No? So not possible. Next 4, 0, 2. Yes, it is there. 4, 0, 2. Next, what is there? 4, 1, 1. Yes, it is there. 4, 1, 1. Sum must be 6. I'm going in order. I hope you understand. 4, 2, 0. 4, 2, 0. Next, that's all. 4, 5, if you go, already it is exceeding. No? So you can't get 6 because all other are 0, greater than or equal to 0 in third one. Okay. That's it, done. Now you have all these possibilities. No? Then from the first combination, what will be the coefficient which will be contributed? So x power 0 is 1, x power 5 is 1, and x power 1, that is 3. So 3 you will get. 1 into 1 into 3. 1, 2, 3 means coefficient of x square, coefficient of x cube. If you multiply, what do you get? 2 into minus 7, minus 14, minus 14 into 2, minus 28. Like this, you keep on writing and add everything. You will get the coefficient of x power 6. Okay. If you do it by any other method, it is going to be equally lengthy or more than that. Okay. Because this is the only way you can solve that question. Okay. Yeah. There are some other ways. That means what you do is you multiply these two, but more or less it is same lengthy only. You multiply these two. What happens? You multiply it directly. You will get these two multiplication, it will convert to one single big term. No? Sorry, not term, one expression. Then you have to think about two baskets only. That time only two baskets will be there. Now, sum of the fruits from fruit packets from those two baskets, total number of fruits must be 6. Then it will be easy. No? Okay. If I, in this case also, if I remove this basket and say total sum of fruits must be 4, how easy it will be? 0 plus nothing, not there. 1 plus 3, 3 is not there. 3 plus 1, so 3, 1 is one possibility. 4, 0, only two multiplications we are getting. Okay. Like now coming to this question, what is there? Coefficient of t power 24 in this. Okay. So first basket, what is it? What are the powers of t which are there? So the powers of t, basket 1, the powers of t which are there is, in this expansion, you know that every power will be even. So what are the powers which are there? That is 0, 2, 4, so on till what will be the highest power of t? 24. So 24 will be there. In the second basket, what is there? Only two terms are there, 0 and 12. In the third basket, it is 0 and 24 because you see this basket. Okay, that's all. No? Now I'll write B1, B2, B3. Now there is no need that you have to approach from B1 only. Okay, let us approach from B3. So that means reference basket, you take something. Always generally reference basket is taken with less number of combinations like this. Okay, so 0 is there. 0, 0, 24, one possibility. 24, 0, 0. Next, 0, 12, 12, possible. No? 0, sorry. 0 is with what here? B3, 0, then 12 and 24. Sorry, not 24, 12. Next, another possibility, 24, 0, 0. 24, 0, 0. That's all done. No? Only 3 combinations. What does this mean? B1 is coefficient of x power 20, t power 24. You know all these things. Now, how to find t power 24 coefficients? You just need to multiply them and then add all of them. That's all. Okay. That is one type of questions which will come. Now, the second type of questions which come is based on series expansion. Okay. I will tell you some shortcuts for that one. Like whenever you expand any binomial, okay, power, that means if you have some x plus y or x plus 1 whole power n, you know that that is nc naught into x power n. Because when you do a plus b whole square, what is the first term which you will write? A square. No? Okay. So highest power will start with the first term. If you do b plus a whole square, then it is b square. Here x plus 1 whole power n. So I'm starting with x power n. Okay. Like that you proceed. No? So I'm not going to take a specific case. Okay, first let me give some formulas, then I will go in general. Okay, the first one formula is like you will see something like this: nc naught plus 3 times nc1 plus 5 times NC2 plus 7 times NC3 plus so on times 2n plus 1 times NCN. This, what is the result there last? Okay. Here, what is the observation? The coefficients are in AP, correct? Sorry, I forgot in the previous question, the two parts I didn't explain. Na? Sum of coefficients of all the terms in the expansion, that is P of 1. Whenever you have a polynomial, let's say a polynomial is there like this, P of x is equals to a0 plus a1x plus a2x square plus so on till an x power n. Whenever you have a polynomial like this, then if you, what will be P of 1? a0 plus a1 plus a2, that is sum of all the coefficients or not. What will be P of minus 1? a0, odd powers wherever are there, you will get minus, otherwise plus. Okay. If you add both of them, P of 1 plus P of minus 1, what will you get? A1, A3, all those will get cancelled, and the right side will be nothing but the sum of coefficients of even powers or not. So what is the this one, sum of powers of even powers? P of 1 plus P of minus 1 divided by 2. And sum of coefficients of odd powers, if you subtract them, then even powers coefficients a0, a2, all those will get cancelled. You'll get 2 times a1 plus a3 plus a5. Okay. So P of 1 minus P of minus 1 by 2, like that. Okay. Done? Yeah. Yeah. Coming to this question. Coming back to this question. Now the coefficients are in AP. And here only one simple basic rule will use. NCR is equals to NCN minus R. Everyone knows, no? Okay. So NCN equals to NC naught. Before that, NCN minus 1 will be there. That is same as NC1, like that. Okay. So first you write down S. S is 1 into NC naught plus 3 times NC1. So when the coefficients are in AP, just you need to write like this. Then same sum you write down in reverse. So 2n plus 1 into, what is NCN? You can write it as NC naught. No? Before the 2n plus 1, 2n minus 1 would have been there. And NCN minus 1 would have been there. That is NC1 only. So next, before that, 2n minus 3 into NC3. And at last, the first term will become the last one. NC naught, you will write it as NCN. Now, when you add them, what do we get? 2 times S is equals to 2n plus 2 everywhere or not? NC naught. 2n plus 2 times NC1 plus 2n plus 2 times NC3. And at last, it will be 2n plus 2 times NCN. That's it. 2n plus 2, if you take common, what is there? NC naught plus NC1 plus NC2. Now, this is standard one only. No? This is 2 power n. So, S will be equals to n plus 1 into 2 power n. Okay. Now, that is one direct formula. For direct formula means basically direct formula will be take average of this coefficient. First, if you understood the process, you will realize why I am doing this. Average of first and last coefficient, whichever is there. What is the average? N plus 1. Average times 2 power n. That's all. That will be the answer. Okay. Next, there is another standard series which is there. It goes like this. One second. Yeah. I will start with an example. 10C0 into 20C10 plus 10C1 into 20C9 plus 10C2 into 20C8. So on till 10C10 into 20C0. What do you observe here? The observation is always this sum is 30. Always. Okay. And always this sum is 10. And if I ask you, add two whole numbers, add two whole numbers to get 10. All combinations. Okay. That means if two whole numbers are added, how do you get 10? All combinations are 0 plus 10, 1 plus 9, 2 plus 8, like that, 10 plus 0, something like that. Okay. Now make sure that what did we say? The sum of this bottom is always same, na? How much it is? 10. Just you need to make sure only one thing. What is that? Is all the combinations of sum 10 is there or not? Only when it is there, you can use this formula. Okay. So now this answer will be, what is the top sum? Always 30. So write 30. C. What is the bottom sum? Always 10. That's all. 30C10 is the answer. Okay. Now, for example, yeah, if some term is missing, if this is missing, then from 30C term, whatever term is missing, 10C10 into 20C0, that you have to subtract. So that is 1 into 1. 30C10 minus 1 will be the answer, like that. Okay. Next. Even if the difference is constant, even if the difference is constant in multiplication, that means 10C0, like you would have seen this formula. What is that formula? NC0 square plus NC1 square plus NC2 square plus NC3 square plus so on till NCN square. Okay. Now, what we will do is, whenever here, if I write it like this, NC0 into NC0, NC1 into NC1, NC2 into NC2, last NCN into NCN. So there are, let us just underline the first terms, okay, or the second term, whichever, anything, it doesn't matter. Okay, 1 second, guys. Yeah, if I underline the second terms, what we will do is, second term you use this formula. Which formula? NCR equals to NCN minus R. So it will become NC0 NCN plus NC1 NCN minus 1, NC2 NCN minus 2. Are you seeing something now? NC0. Now, once you use that formula for one of the whatever product binomial coefficient which is in multiplication in each term, you will observe that always the bottom sum is always what here? N. It is just like the above one only. Na? Bottom, if you add these two below ones, it is always N. If you add the above ones, always it is how much here? 2N. Now, only one thing you need to make sure. What is that thing which you need to make sure? Are all combinations of N are there? Yes. Because two numbers, if you have to add to get N, means 0 plus N, 1 plus N minus 1. From there you will start N plus 0. All are there. No? So finally the answer will be sum of 2N, that upper sum, below one sum is N. So 2NCN is the answer. Okay. Fine. So, okay, I think the time is done. Okay. These were very lengthy topics, complex numbers and binomial theorem. Okay. Whatever we could do, we have done. Okay. Just again, I'm repeating, guys. Just make sure you are doing the previous JEE mains questions on the topics which are discussed on that particular day. Okay. If that you do, that should be enough. Fine. Okay, guys. Thank you, everyone. Okay.